All right, chap. All right. Welcome to Mathman Mondays. Today we're doing systems of equations. We're going to be talking about substitution and elimination, specifically with like two variable equations. So that way we don't get anything too crazy today, because if we do three-step equations, that's going to add a ton of time. So that'll be a video for another day. Hope everybody's doing well today on this fine Monday. And let's just jump right in. All right. So systems of equations, we have a few things that we want to talk about with these. And first of all, when we're talking about systems of equations, is we want to think about their graphs. And really, we have three different types of solutions we can run into. So for types of solutions, we can talk about three graphs. So 1, 2, 3. Those might be sort of poorly drawn, but that's fine. And we're going to talk about if we have a line. We can talk about, we can go like this with another one. And then on the bottom, I'm going to use green, even though it's really hard to see for some reason. Probably because I need to order new markers. I need to set a reminder. Order new markers for Mathman Mondays. And we'll set, horizontal is probably not the best option here. Let's just say we have one like this. And really what we're going to see is we have three different types of solutions. So here we could have a line that's coming across and going like this. Here we might have a parallel line. And here the lines are actually one. They're the same line. And these solutions give us, if we have this singular point where they intersect, this is called a consistent solution. If we have parallel lines where the lines never intersect, this is called inconsistent. And then finally, our last one, if the two graphs end up being the same line, this is called consistent dependent. All right, so when you're doing these problems, you're either going to get a point where they intersect, which is most often what we're going to get. Inconsistent, where you get two parallel lines, so you notice that in their slope if you solve for y. And consistent dependent, where on both sides of the equal sign, you have either the same equation or you work it down to be the same number. I'm making up all the problems today, so hopefully we see some of each, but no guarantee on that. And we're going to start with substitution, which I think is probably the harder method that we have to go with. But all in all, we're going to talk about substitution first. So keep in mind that if you're struggling with substitution or elimination, you can always solve each of the equations for y, graph it, and if it intersects, you can use that point. Wherever the intersection, that's going to be your x and y value. If they don't intersect, you know it's inconsistent. If you only have one line, you know it's consistent dependent. So you really don't actually have to do all that much work if you already know how to solve linear equations, which is something we have talked a little bit about. So moving right along. It might help if I had my eraser on me, and I don't. So let's go grab that real quick. When we talk about substitution means we're going to solve for one variable. In this case, we're only going to be using x and y tonight. We're going to solve for x or y. It's your choice on what you want to do. And once you solve for x or y, you're going to substitute it into the second equation. So if we're talking about substitution first, I always feel like I spell substitution wrong. What up, Ross? If we're talking about substitution, we want to go, and let's say we have 2x plus y equals 5, and then we have x minus y equals 3. All right. Whoa, that wasn't good. Sorry about that. Took everybody on a trip there when I was moving stuff around. That was terrifying. All right. Usually I like to think about this for later on. I like to label these equations equation 1 and 2. You don't have to do that, but I like to do that just to keep track of what's going where. So you're going to, as I said before, when you're doing these, you're going to solve for x or y, then substitute into the equation that wasn't used. Okay. And really, I'm going to use equation 2 because we already have x minus y equals 3. And I'm just going to solve it for x because I have a negative y. So this gives me x equals, if I bring y over, I add it, so I get y plus 3. And now that I have x solved for, I'm going to use my first equation, which, if I go back to, that was 2 times whatever x is, I just solved for that, plus y equals 5. And when I substitute my value for x in, I'm going to plug in that y plus 3. And then I need to go through and distribute. All right, that is a key component here. This 2 needs to go to that y and that 3. And that gives me 2y plus 6 plus y equals 5. And then I'm going to combine like terms. I end up with 3y plus 6 equals 5. And then I end up with, if I subtract 6 from each side, 3y equals negative 1. Y equals negative 1 over 3. Now, this is why I don't like making up these problems, because we get fun fractions. All right, but that's okay. We're going to just label off a space for us over here to go ahead and solve for x. We know what y is now. Y is negative 1/3. So we go back up here where we solve for x, where x equals y plus 3. And we say, hey, well, we can now find out what we need to know. We can say x equals our y value, which we're going to plug in and add 3. Well, our y value is negative 1/3. And in a way, I'm kind of glad we got a fraction, because what I want people to do is be comfortable seeing these fractions. It's always a struggle. And you need a common denominator of 3, which means I'm going to multiply 3 by 3 over 3. Last time I checked, 1/3, 3 times 3 is 9 over 3. If I said 9 divided by 3, I get 3 back, so I know I'm right. Negative 1/3, let me angle this slightly better. Negative 1/3 plus this 9/3 is going to give me a 8/3. All right, so now I've found an x and y coordinate where these work. And really, I can go back down and look at this. I have y is negative 1/3 and x is equal to 8/3. If I graphed my two equations that were up top, and I said, hey, let me solve each of these for y, and I graphed them, I would find out that they intersect at the point negative 1/3 and 8/3. All right, so nothing too crazy. Let's look at another one, and hopefully maybe I can make something a little bit more interesting, but we shall see. I need to find a better way. If anybody has an idea about how to find a better way to get cameras onto these boards, or if I just need to order a bigger board, if you got some ideas, shoot them my way, because I'm really trying to find out a better way to get this filmed for you guys. I've talked to the people that made these board, Deco. I've talked to Deco about getting a bigger board, and I think that might be a solution for my problem, but that's a conversation for another time. So, if we have another example, let me think here. If I can do this right, it'll be okay. We'll do 2x plus 4y equals 12. Will that work? Yeah. And if I have this one that says x plus 2y equals 6. All right. If I solve these, and we'll look at this, when we start elimination, we'll look at this exact same problem. If I solve, and again, I'm going to think about this being like equation 1 and equation 2, just so I can keep track. That's not a huge deal now, but when we get to 3-step equations, which again, we're not doing tonight, but we'll look at some on a different video, when we have x, y, and z, then we want to make sure those equations are labeled or else they'd get messed up. So we're going to go through and we're going to solve for x. And when we do that, we end up with x is equal to negative 2y plus 6. It's kind of written off pretty poorly there to the side. Let me erase that real quick. X equals negative 2y plus 6. Bamboozle. There we go. All right, so and we used equation 2 for that. Make a little notation there. Now what we're going to do is we solve for x. So we're going to say, hey, let's look at equation 1 and substitute in. So we have 2 times our x value we're going to substitute in plus 4y equals 12. Now, when we do this, we are substituting in that negative 2y plus 6. So negative 2y plus 6. And the good news is, again, we are going to distribute. Boom, boom. All right, with distribution, we end up working this out and we get negative 4y. So minus 4y plus 12 plus 4y equals 12. Well, if I'm looking at this, I'm like, man, I got a negative 4y and a positive 4y. Well, 4y minus 4y gives me 12 equals 12. When you get this type of solution where they're equal on both sides, this is when the lines are actually the same. So we go and we have consistent, dependent as our solution. And really, again, if you go back and you substitute, or if you solve these each for y and you graph them, you would see that they're the same line, and then you'd be fine. Now, that's pretty much it for substitution. It doesn't really get any more intricate than that. You're always going to solve for a variable and then substitute it into the other equation. Obviously, we could also get the idea of inconsistent, which would mean I'd get 12 equals a number it doesn't equal, like 0 or 5, anything. So inconsistent is another option there, and you'd see that with parallel lines. So if we go back now, and let's talk about elimination, which we haven't discussed. We've only talked about elimination, but we're going to, or substitution, sorry. We're going to use the same equation. And the way elimination works is elimination, you want to find something that they have in common. So for elimination, oops, it might help if I erase the top and rewrite the title. Big math indeed. All right, so in this time we're going to do elimination. So when we talk about elimination, our goal is to, I don't want to say, multiply. You could put or divide, but really you're going to multiply most of the time. To get an opposite sign and same coefficient for a variable term. All right, and that might sound kind of crazy, but it is what's going to happen. We're gonna pick a variable. We can pick x or y, and then we're going to multiply it by a value of opposite sign if needed, and then we're going to turn it into a giant addition problem. And the reason automatically I know that this is going to be a consistent dependent solution is because of elimination. I prefer doing elimination over substitution, but it really just depends on which one you prefer to do. So again, I have these labeled equation 1 and equation 2. And if I say, hey, I want to get rid of x. Well, if I want to get rid of x, I can multiply everything in equation 2 by a negative 2. And when I do that, I'm going to get a negative 2x minus 4y equals a negative 12. The idea of elimination is I take that original equation, which was 2x plus 4y equals 12, and I change it into a giant addition problem. So negative 2x and 2x gives me 0, plus negative 4y plus 4y gives me 0, equals negative 12 plus 12 equals 0. And then as soon as that happens, in other words, they're the exact same equation, Then I'm back down here and I say, hey, consistent dependent. Which in my opinion is a much faster solution to our problem. Okay, so let's look at a different problem that's not so obvious and isn't going to just, work in our favor so easily. So we're going to take a new problem and we'll make it up and just see how it goes. Maybe it goes good, maybe it doesn't. That's the fun end of making up problems. I mean, yeah, it is basic system of equations. At the beginning of the stream, I said today is going to be 2 variable system of equations, nothing crazy. Sorry if you're expecting like 3-dimensional objects and stuff. That's not today. For a different day. All right, so if we're doing an elimination of a different problem, we could do, let's think. Let's say 3x plus 7y equals 15. And then we'll do, actually, let's change this. Let's make this like, I don't know, 9. That way we have like, we'll do a negative 3x minus 14y equals 6. And just see what happens. All right, again, we're just looking for something to have in common. In this case, we have a couple options. You could multiply to get a commonality with the x. You could divide to get a commonality with the y. The problem with dividing is when you divide, this becomes 3/2, and you probably don't want to work with it too much with this being a 9x. Sorry about the glare there. And then you end up with, and the fraction here would be too bad, but you end up with a fraction with the 3/2, which would cause you a problem. So we just look at this part, and we say, hey, we're going to multiply that by 3, and we do that. Our new equation is going to be negative 9x minus 3 times 14. So we get 12, carry the 1, 42y, and then 18. And then we're back to just adding that to the first equation. So our first equation was 9x plus 7y equals 15. Again, this is like a giant addition problem. This problem is going to get ugly really fast. So our solution here, these are going to cancel out. We have a negative 42y plus 7y. So we get a negative 35y is equal to, oh hey, this isn't actually too bad, 33. It's actually sort of terrible. All right, y equals negative 33 over 35. I might have to make a note of that, but we'll just use another board. Let me get, it doesn't matter which one of these we want to use. We can use either one. I'm going to go ahead and stick with the first equation. So we'll have 9x plus 7 times negative 33 over 35 equals 15. And this is why you don't make up your own problems. All right, so we have a y value, and that y value was negative 33 over 35. In this case, you're going to be working with some large numbers, and that's okay. Typically, we probably wouldn't be dealing with this. It'd be a better design problem, but I figured, hey, why not? Let's just try something random and see what happens. So, if we're working this out, let's make sure we got this. So, negative 33 times 7, we get a negative 231. So we have 9x plus, and we'll go ahead and change this to a decimal, divided by 35. And that gives us a negative 6.6. And really, we could have done that here and did some nice reducing there, but it's not that big a deal. And then we're going to say 15 plus 6.6 to both sides and get 21.6. So 9x is equal to 21.6. We're going to divide that by 9, and x is going to equal 2.4. So again, if you solve both of those equations for y, then your x and y coordinate, your y would have been 33 divided by 35, and it was negative. So it would have been negative 0.943 as an approximation. But that gives you an idea. This was obviously a much harder elimination problem in the sense of dealing with a fraction than what you normally have to do. But again, this falls into that category of as soon as we see we have a point of intersection, this is called consistent. All right, short and sweet and to the point. Like I said, when I started stream tonight, this was going to be basically two variable systems of equations. I was going to leave 3 variables for another time just because they get pretty intricate in the sense of like you have to keep track of 6 equations. So I wanted to start off with the basics today so that way we could do a stream about the more difficult ones at a later time. So sorry about that. I know somebody in the chat said that this was pretty basic. Yeah, it is. Part of the Math Mondays is I do some basic stuff. I had a day where I did fractions. I had a day a couple weeks ago where I did calculus. I just kind of mix it up and we, go with it. So some days are really easy. Some days are hard. But, just because it's easy for one person doesn't mean it's easy for everybody. So please keep that in mind. We're out here trying to, help people out. So there are people that do struggle with substitution and elimination. Or just, solving for y, like linear equations. That's fine. I'm just hoping to help some of those people out. So, like usual, I will be uploading this tomorrow, or hopefully tonight, but worst case tomorrow. So it'll go to YouTube, which is linked below. So if you want to check it out there, you can. Always feel free to leave comments there, and I'll try to get back to you as soon as you can. If you want to leave me a comment on Twitter, go to my Twitter. There's a link for that below. You can shoot over suggestions of things you might want to see, questions you might have, things of that nature. If you're interested in any of these types of boards, let me know. My friend works at Deco. I can get you his contact information if that's something you're interested in. Overall, hope you all enjoyed the content. I'm going to be switching over to some gaming, but I hope this helped out some people in the long run. Thanks for stopping in, and I'll be back here in a little bit, or probably a couple minutes.